Okay, picking up where we left off, we'll display the header strings variable to remind ourselves of the names of the columns containing only string values. If it's still unclear what the data stored in these columns represents, we can refer to the dictionary file which accompanies the dataset. The first column is called Issue D, which is short for issue date, and refers to the date on which the loan was approved. Since we like our column names to be descriptive, let's rename it. To do so, simply use indexing to set the first value of header strings, the one with index 0, equal to issue date, in quotation marks. Great! To see what it looks like, let's display the dataset. We see this column stores the month and year for every account, so it holds information we can use when analyzing the dataset. Let's examine it more closely. For starters, we can go to a new cell and only display the contents of the first column of the string dataset. By the looks of it, there is a fixed format here. Every month is expressed with the first 3 letters of its name in English, followed by a hyphen, and the year of the loan. To check if this is true, we can use the unique function to display all the different values within the column. The output consists of an empty space that represents missing data, and 12 other strings that match the pattern we described a few seconds ago. The values are arranged in alphabetical order, rather than chronologically, since they are simply text and Python doesn't recognize them as timestamps. Regarding the year, we notice that all the loans are from 2015. This means we can strip the -15 part from every element of the column, without losing any insightful information. To do that, we'll call the strip function and plug in the first column of the strings dataset as an input. Then we'll specify in quotation marks the part of the text to be removed, -15, and run the cell. Now each value of the new array only holds the 3 letters for the corresponding month. This is great, but don't forget that the function doesn't automatically remove these values. So we need to overwrite the given column by assigning to it the output of the function. All right. If we call the unique function again, we'll see a confirmation that none of the elements of the column contain the year. So we've successfully shaved off some excess data. However, what you'll often do in analyses is represent month values as integers. This approach will allow us to store the data using less memory, as integers take up less space compared to strings. By using numbers, we'll also achieve a more easy-to-follow order of the months. To apply this trick into practice, we'll use NP_where to substitute Jan for 1, Feb for 2, and so on. One way to elegantly solve this is to define an array or list with the proper order of the unique values in this column. For this current task, both data types are equally viable, so we can use an array for the sake of consistency. So we create a variable called months and assign to it the output of the NP array. In the parentheses, we'll add a list that begins with an empty space, followed by the months of the year, in their proper order. Then, in a new cell, we'll use a loop to traverse the issue date column and assign a numerical equivalent to each of its unique values. As we said earlier, we'll switch out January for 1, February for 2, and so on. And we'll also set missing values equal to 0. We want to separate it from the rest because we will attribute the annual values to candidates who have no issue date on record. Right. The most straightforward way to do so is via the for loop. The iterator variable I will be in range 13. Hence, I will take all the integer values between 0 and 13, excluding the latter. This is because intervals in Python are mostly closed open, meaning the bottom value is included, but the top isn't. Inside this loop, we'll assign to the issue date column the output of NP_where. The function checks whether the value from the column equals a specific value from the months array we defined a minute ago. If so, then it assigns the corresponding numerical value, and if not, the issue date remains unchanged. Since we have the empty space in the starting position of the months array, the first iteration of the loop will fill out all missing values with 0. Then all the Jan values will be replaced with 1, and so on until Des is substituted for 12. Once again, we rely on the unique function to verify that there is no longer an empty space at the start of the output array. Instead, we now have a 0. This is how we managed to transform the entire issue date column into numbers. However, we won't cast the values into integers right away. Instead, we want to go through all the string columns and change the type of the entire dataset simultaneously. This is the topic of our next lesson. Until then.